Fuses and circuit breakers can indeed be installed in metal wireways under specific conditions and in accordance with electrical codes. The National Electrical Code, or NEC, provides guidelines on the proper installation and use of wireways, including those containing overcurrent protection devices. Firstly, it's crucial to understand what a wireway is. A wireway is a sheet metal trough with hinged or removable covers for housing and protecting electrical wires and cables. They are designed for installation in locations where wires and cables are exposed and may be subject to physical damage or environmental conditions. Secondly, consider the NEC requirements. The NEC addresses the use of wireways in Article 376. This article outlines the permitted uses, installation requirements, and construction specifications for wireways. Specifically, the NEC allows for the installation of fuses and circuit breakers within wireways if certain conditions are met. One such condition is that the wireway must be accessible. Accessibility, as defined by the NEC, means capable of being reached for operation, renewal, or inspection without requiring those to whom ready access is requisite to climb over or remove obstacles or to resort to portable ladders, and so forth. This requirement ensures that the overcurrent protection devices can be readily inspected and maintained. 2. The wireway must be properly grounded. Grounding is essential for electrical safety and helps to prevent electrical shock hazards. The NEC requires that wireways be grounded in accordance with Article 250, which covers grounding and bonding. 3. The fuses and circuit breakers must be of an approved type for use in wireways. Approved, according to the NEC, means acceptable to the authority having jurisdiction, or OJ. The HA is the entity responsible for enforcing the electrical code, such as the local building inspector or electrical inspector. The HA may have specific requirements for the types of fuses and circuit breakers that are permitted to be installed in wireways. 4. The wireway must be sized appropriately for the number and size of conductors and overcurrent protection devices installed within it. The NEC provides tables and guidelines for determining the proper size of wireways based on the ampacity of the conductors and the physical dimensions of the devices. Ensuring that the wireway is adequately sized is critical to prevent overheating and potential fire hazards. 5. The wireway must be installed in a neat and workmanlike manner. This means that the wires and cables must be properly supported, secured, and identified. The wireway must also be free from sharp edges, burrs, and other defects that could damage the conductors. 6. The wireway must be protected from physical damage. If the wireway is installed in a location where it is subject to physical damage, such as in a manufacturing facility or construction site, it must be protected by additional means, such as by installing it in a conduit or by providing barriers or guards. 7. The wireway must be properly labeled. Labeling is essential for identifying the purpose of the wireway and the circuits it contains. The NEC requires that wireways be labeled with the voltage, current, and other pertinent information. In addition to the general requirements outlined above, there may be specific requirements for the installation of fuses and circuit breakers in wireways depending on the application. For example, if the wireway is used to supply power to critical equipment, such as emergency lighting or fire alarm systems, there may be additional requirements for the reliability and performance of the overcurrent protection devices. Furthermore, it is essential to consider the environmental conditions in which the wireway is installed. If the wireway is installed in a wet or damp location, it must be rated for that environment. Similarly, if the wireway is installed in a corrosive environment, it must be made of a corrosion-resistant material. It's also important to be aware of any local codes or regulations that may apply to the installation of wireways and overcurrent protection devices. Local codes may be more restrictive than the NEC and may impose additional requirements. When installing fuses and circuit breakers in wireways, it is essential to follow the manufacturer's instructions. The manufacturer's instructions provide detailed information on the proper installation, operation, and maintenance of the devices. Ignoring the manufacturer's instructions can lead to improper installation, equipment failure, and potential safety hazards. In summary, while fuses and circuit breakers can be installed in metal wireways, it is crucial to adhere to the NEC requirements, local codes, and manufacturer's instructions. Proper installation and maintenance of wireways and overcurrent protection devices are essential for electrical safety and system reliability. Always consult with a qualified electrician or electrical engineer if you have any questions or concerns about the installation of electrical equipment. It's also crucial to remember that electrical codes and standards are constantly evolving, so it's important to stay up to date on the latest requirements. The NEC is typically updated every 3 years, so it's essential to ensure that you are using the most current version of the code. Additionally, it's important to understand the different types of fuses and circuit breakers that are available and to select the appropriate type for the application. Fuses are typically used for overcurrent protection in residential and commercial applications, while circuit breakers are typically used in industrial applications. There are also different types of fuses and circuit breakers that are designed for specific applications, such as motor protection and transformer protection. When selecting fuses and circuit breakers, it's important to consider the voltage, current, and interrupting rating of the device. The voltage rating of the device must be equal to or greater than the voltage of the circuit it is protecting. The current rating of the device must be sized appropriately for the load it is protecting. The interrupting rating of the device must be sufficient to safely interrupt the maximum fault current that could occur in the circuit. In addition to selecting the appropriate type of fuse or circuit breaker, it's also important to properly maintain the devices. Fuses should be inspected regularly for signs of damage or deterioration. Circuit breakers should be tested periodically to ensure that they are operating properly. If a fuse blows or a circuit breaker trips, it's important to investigate the cause of the overcurrent condition before replacing the device. Replacing a fuse or resetting a circuit breaker without investigating the cause of the overcurrent condition can lead to a recurrence of the problem and potentially to a more serious electrical hazard. Another important consideration when installing fuses and circuit breakers in wireways is the ambient temperature. The ampacity of conductors and overcurrent protection devices is affected by the ambient temperature. If the wireway is installed in a high-temperature environment, it may be necessary to direct the ampacity of the conductors and overcurrent protection devices. The NEC provides tables and guidelines for directing conductors and overcurrent protection devices based on the ambient temperature. Furthermore, it's essential to ensure that the wireway is properly supported and secured. The NEC provides guidelines for supporting and securing wireways based on the size and weight of the wireway and the spacing between supports. Improperly supported wireways can sag, twist, or break, which can damage the conductors and create a safety hazard. When installing wireways, it's also important to consider the potential for condensation. If the wireway is installed in a location where condensation could occur, it may be necessary to provide drainage holes or to use a wireway that is designed to prevent condensation. Condensation can damage the conductors and create a safety hazard. In addition to the above considerations, it's also important to be aware of any special requirements that may apply to the installation of wireways and overcurrent protection devices in hazardous locations. Hazardous locations are areas where flammable gases, vapors, or dust may be present. The NEC provides specific requirements for the installation of electrical equipment in hazardous locations to prevent explosions and fires. When installing wireways and overcurrent protection devices in hazardous locations, it's essential to use equipment that is specifically designed and approved for use in those locations. This equipment is typically explosion-proof or intrinsically safe. Also, always remember to energize the circuit before working on any electrical equipment. Working on live electrical equipment can be extremely dangerous and can result in serious injury or death. If you are not qualified to work on electrical equipment, it is essential to hire a qualified electrician. Electrical work should only be performed by qualified individuals who have the necessary training and experience. In summary, the installation of fuses and circuit breakers in metal wireways is a complex topic that requires careful consideration of the NEC requirements, local codes, manufacturers' instructions, and other factors. Proper installation and maintenance of wireways and overcurrent protection devices are essential for electrical safety and system reliability. By following the guidelines outlined above, you can help to ensure that your electrical system is safe and reliable. Remember that electrical work can be dangerous, and it's important to take all necessary precautions to protect yourself and others. If you are not comfortable working on electrical equipment, it is always best to hire a qualified electrician. Always double-check your work and test the system to ensure that it is operating properly before energizing the circuit. By following these guidelines, you can help to ensure that your electrical system is safe and reliable. Also, it is important to have arc flash protection while working on electrical equipment. Arc flash is a dangerous electrical explosion that can cause serious burns, injuries, and even death. When working on or near energized electrical equipment, it is essential to wear appropriate personal protective equipment, or PPE, to protect yourself from arc flash hazards. PPE may include arc-rated clothing, gloves, face shields, and other protective gear. Additionally, it is important to follow safe work practices, such as maintaining a safe distance from energized equipment and using insulated tools. Arc flash hazards can be reduced by implementing engineering controls, such as installing arc flash barriers and using remote racking systems. An arc flash study is used to determine the potential arc flash hazards in an electrical system and to identify the appropriate PPE and safe work practices. These studies must be performed by qualified individuals who have the necessary training and experience. In addition to arc flash hazards, there are other electrical safety hazards that you should be aware of, such as shock hazards, electrocution hazards, and fire hazards. Shock hazards occur when you come into contact with energized electrical equipment. Electrocution hazards occur when a large amount of electrical current passes through your body. Fire hazards can occur when electrical equipment overheats or when there is a short circuit. To protect yourself from these hazards, it is important to follow safe work practices such as de-energizing the circuit before working on electrical equipment, using insulated tools, and wearing appropriate PPE. Also, it is important to inspect electrical equipment regularly for signs of damage or deterioration. Damaged or deteriorated equipment can be a safety hazard and should be repaired or replaced immediately. Finally, it is important to be aware of the emergency procedures in case of an electrical accident. Know where the emergency shut-off switches are located and how to use them. Know how to call for help and what information to provide to the emergency responders. By being prepared for electrical accidents, you can help to minimize the damage and prevent serious injuries. When working on electrical equipment, it is also important to be aware of the potential for static electricity. Static electricity can build up on your body or on the equipment and can discharge unexpectedly, causing a shock or other injury. To reduce the risk of static electricity hazards, it is important to ground yourself properly before working on electrical equipment. This can be done by touching a grounded metal object or by wearing a grounding strap. Additionally, it is important to avoid wearing clothing that is made of synthetic materials, as these materials can generate static electricity. When installing wireways and overcurrent protection devices, it is also important to consider the aesthetic appearance of the installation. Wireways should be installed in a neat and orderly manner and should be aligned with the building structure. Overcurrent protection devices should be installed in a location where they are easily accessible and visible. In some cases, it may be necessary to conceal the wireways and overcurrent protection devices to improve the aesthetic appearance of the installation. This can be done by installing them behind walls or ceilings or by using decorative covers. However, it is important to ensure that the wireways and overcurrent protection devices are still accessible for inspection and maintenance. Finally, it is important to document the installation of wireways and overcurrent protection devices. This documentation should include the location of the wireways, the size and type of conductors, the rating of the overcurrent protection devices, and any other relevant information. This documentation can be used to troubleshoot problems with the electrical system and to ensure that the system is properly maintained. In addition to the above considerations, it is also important to be aware of any environmental regulations that may apply to the installation of wireways and overcurrent protection devices. Some environmental regulations may require the use of specific materials or the implementation of specific practices to protect the environment. For example, some regulations may require the use of lead-free solder or the proper disposal of hazardous materials. It is important to consult with a qualified environmental professional to ensure that you are complying with all applicable environmental regulations. When working on electrical equipment, it is also important to be aware of the potential for electromagnetic interference, or EMI. EMI is a disturbance that can affect the performance of electronic equipment. Electrical equipment can generate EMI, and it can also be susceptible to EMI from other sources. To reduce the risk of EMI problems, it is important to use shielded cables to ground the equipment properly and to follow good wiring practices. It is also important to locate the electrical equipment away from other sources of EMI, such as radio transmitters and microwave ovens.